minutes, then Penny says it's time, right? I just said it's simple, right? Said it's simple, right? As simple as time. If time is 1 bit, then become 0 and 1. Can we set time as 0 and 1? So now think of, we just talk about lights. Can we set the lights stays at 0 and 1? Yes. So what is the 0 and 1? On and off. All right. Can we set time as 0 and 1? Can we set 0 and 1 for time? So we'll try to make it simple, right? So if we wanted to set time as 0 and 1, what does it mean? First one, can we? If you cannot, why? If you can, then how to set it? Hurry?
It can, because maybe you can set the maybe time 0 is green and time 1 is red. It's more like timing.
We still have yellow, right? We have red, green, and yellow, right?
But yellow still can pass.
Can pass?
Yeah.
No, yellow is yellow, right? Yeah, you can move it quickly, right? Drive it quickly, but it's yellow. Yellow is different from red, right? It's different from green. Which one will change to yellow, green, or red?
Green.
Green. Red will not change to yellow, right? So only green can change to yellow, right? So we have 3 kinds of lights, right? The color change. We have green, we have yellow, and red. So only green to yellow, right? And red, right? But when we wanted to look at the main streets, when the main streets, right, there's green and the other sides, right? The side street would not the same, right? So every situation they will not be same. Okay. So suppose our input is time, and we wanted to set it's 1 bit, 0 and 1. What does it mean? Light is light, right? So no, it's the time, right? Timer, right? So timer. What does it mean that the timer that's 0 and 1? So if our inputs, your input is time, right? So time. What does it mean 0 and 1? Do you understand that? Okay, all right. You said change the lights. I said that.
Yeah, when the traffic light is green, the main street is green. That is the time 0, and the sign is red. The traffic light is red. It's the time 0, and time 1 is the main street is red, and side street is green.
Make sure what you said. If we have time, it's a time, right? Suppose the time t. So time 0. It could be, the input here, right, is time, right? So time will be the state. You just said that it's a main street, right? So main street, now we suppose that we have main streets, right? North south is main streets, east west, the side streets. All right. So we now we need to look at them simultaneously. So there is that, well, this and that. Yeah. North south, north south that's green, right? Suppose it's green, or you put it green, right? Then what about the east west will be green, red. And here, what situation that will remain here? And then we'll go to, it's going to change, right? And so I can use this. What will change for north, south? Red, red, yellow, red, okay. And the time, so 1 time, it says time is 1. When time is 1, what does it mean? Uh, no, that's not. That's not the answer. If time is 1, what does it mean? Right. Tell me that, can we change the state from this to, what about the next state? North, south, red. So, yeah, still can change the states. Is that red? And what about east west? Yes. Oh, okay, okay. It's a green. Can we change it again? The next. Right? Can we change it again? What? What would be?
NS is red and EW is Yellow.
Right? No. No, we change back. No, we can change back. All right. So, yes. Ellen, so how many states for this example, traffic lights with intersection? How many states? 4. Good. 4 states. All right. So now, any single states, we need to look at the combinations of 2 targets, right? That's different from what you have none that's lies on, lies up. If your 2 targets is going to depend, right? Depends on the other, then you need to look at them together. Like this example, right? So we cannot just look one. We need to look both sides. So we have 4 states, right? 4 states. But usually when we write code, 4 state 1, 2, 3, 4, and we start from 0, right? So presume that we can write as states. 0, 2, 3. That means we have 4 states. Okay? 4 states. Can we change this to 2 bits? The expressions of 2 bits. Can we change it to 2 bits? Raise your hands, you understand that. Okay, Alex, what would be the 2 bits?
The original one, the 0 is B00.
This one will become 0, 0, right?
Yes.
And what about this one?
0, 1.
0, 1. Nice.
1, 0, and 1, 1. And the last is 1 and 1.
So it will be 2 bits. All right. So we can change this to 2 bits. Okay. And now we know that here we haven't solved the problems about time, 1 and 0. What does it mean? 0 and 1. Now we know that, well, it's the first states, we keep it 0. Second, third, and fourth, we have 4 states. And each state is a combination, right, of 2 targets because that depends on each other. So we need to look at them simultaneously, right? So 4 states. And the time, right? We have a timer tickering down. What does it mean? If we set, let's say 60 seconds, right? Tickering, done. So here becomes 0. And all the tickering down, count down it, that's 1. All right, still have time remaining, that's 1. That's a 0, right? So what do you think about the states? So this one, time is 1 or 0? this. Each state, you need to have inputs and outputs. Right, that's the inputs. What is the inputs? If it's a T. It's a T. What would be the inputs? What do you think about inputs? Which is one? It's a one or this is one? Transition is one. From 0 to 1. It's a 1 or 0.
I think they both can be one.
Both will be 1.
Yes.
If both will be 1, then what does it mean?
Because in my opinion, the 0 means the green light, the countdown number is greater than 0. And the 1 means the green light countdown number is equal 0.
So here
So-
it says 1 and 1.
Yes.
So your countdown. So what do you think? It could be yes or no. So countdown. What do you think? So we set it as a 60 seconds. All right. 6 seconds. Then go to here. 6 seconds. Or countdown 0, then go to next. Is this reasonable? Is this reasonable, guys?
Which one?
1 and 1. So when we set the time, right, the timer is come down. If we set the timer, then it will remain inside the state until reach 0 and go to next, right? So this is not reasonable. Not reasonable, all right. How could it be, count down and go to, no. But here, right? So if the timer, right, we set it 0 and 1. That means when count down, we set a time. And it happened here. What is 0? Is to go to the next state. You guys understand that? All right. So then tell me that how many outputs? It's hard. How many outputs? It's going to let you see this. So, it's going to see the jet here. So we presume everything that's 1, no 0. Right? So everything is like that. Everything that's 1. Then 0 is meaningless. Let's see here. All right. So we start from the first state. So first state could be something that's right. We are going to set right the initial right. We set it. So you're going to see that the time that is 0, right? We encounter something, right? So probably a vehicle approaching. A vehicle is approaching, right? So now we are going to set that now it's green, right? Green to red, right? We set 60 seconds, right? Now it's initial. So the state is mobilized. 60 seconds, right? So we are going to change to the second state. 60 seconds. We set it 60 seconds until 0. We just started, and then we set a time until 0. When it's 0, you go to the next state. So it's going to see no, right? If you think about that. You have 0 and go to the next state, and that's count down, right? 0, go to the next state. The same. You can reset it, right? So this is the state change. But how many outputs? What's the outputs? This state. What's the output? So we have inputs. It's time, right? And we set this as 1 bit, 0 and 1. Presume 0 has come down to nothing, right? So we have to initialize it and go to that. What's the outputs? You think that's light change. No one knows the outputs. So what's the output? What do we expect? What do we expect? It's a traffic light. What do we expect the outputs? What? What would be the outputs? Yeah. Yes, because we expect lights, right? The outputs? What's the outputs? Yeah. Yeah, so we expect lights on, right? It's red, right? It could be yellow, right? Yeah, we expect that. So the outputs. So what's the outputs? We have inputs. So time. We have time, right? Here become inputs. Input resets, right? Resets. The time. In the output, we expect the light, right? So it's a green. So how many outputs? How many outputs? The color change. How many outputs? So wanted to answer the question. Say Ian, right? No, not Ian. Is it Tino?
Maybe
is eight output.
8 outputs.
Uh,
So what was the 8 outputs?
three bits of 8 output.
3 bit.
Yeah.
What's the three bits outputs?
Timer and
What's the 8 outputs? What is? It says 3 because we have 3 colors, right?
yeah.
Okay, 3 color. Oh, I see. I know what you mean. Right. Color change. So how many output do you think? Rabbits. Rabbits. It's a red, yellow, green. Rabbits. Then the outputs. Green. So green, yellow, and red. And what's the 8 combination? So, we have green, right? Green, yellow, red, right? And then another side. So another side, you say another side. So here there's one side. No sauce. The same. Another side is west. It's only 6. So 8 bits. It says 3 bits. 3 bits. So that's not bits. All right. So expect the outputs. No sauce. It could be green. It could be yellow. It could be red. All right. And east west the same. But since it's green, different sides. So here, like this. All right. So we have 6 outputs. The color change. The color change. So we know that, and I just said that we can change the states as 2 bits. Because 2 bits, well, that's would be nice for us to see their change. Okay, draw that is. So here, that's the states, all right. Then if we use 0, 1, 2, 3, we can see their combination, but we want to separate them. So now, yeah. Okay, zero, right? It's 2 bits. Right. So these states we're going to separate 0 and 1 1. From here, then we can look each one. So we need to draw this table. From here, we know that it just stays, no. Only 2 that's positive. All right. And we said that if that's a positive, it will be 1. If it's a negative, none, that it will be 0. 0 and 1. All right. So, how to fill 0 and 1 from this? And the table, this table, we call it as a truth table. Truth table. Okay, and calling, come here, fill this one. Carry this column. Jason, the third. Tom, the fourth. Jack, the fifth. Back to Jack. Okay. And without
So we can see a green, yellow, and red light. So when the value is 1, it represents the light is on. So okay, let's see the state. So for the state 0, we can see the here we can see the green light is on and the red light is on too. So here should be 1. And the state 1, we can see the lights on yellow for the north and south, yeah. And second light on is the east-west red. So we can check here. Here is right, and okay, here is right too. For the state 2, we can see the north-south red light is on, and the east-west green light is on too. So we can check. Here is right, and here is right too. And the last one is this north-south red light on. Okay, red light is on, and the east-west yellow is on. So okay, that is correct.
For the paper, right? Paper reports, you can hand it over to TA. TA said 1 is enough. Okay, so that's need to turn it on June the 3rd, right? And I highly expect that pencil diagram in a readable way, right? Increase the readability, please, right? The first question will not affect the grade, right? The first question, you can choose do or not do, right? They will not affect your teamwork too, right? So the first question is going to separate that. So I want you to attach the revised TW1, right? And mark the revision points, right? That's an option. I say this option. If you choose not to revise, fine. They will not affect TW2. But you choose modify, right? You choose to modify it, and I will regret it, right? The second question is, related to today's. So I want you to describe some pieces of your team project. The sequence of diagram by using synchronous, asynchronous, and working. And write the code respectively, right? And that is working, synchronous experiments, right? the other I will not explain because we haven't go here, right? So, and the last question, this one will be graded separately surround the prototype. So for the final, teamwork to, pay attention on this teamwork, and you still have opportunity to rewrite your teamwork one, right? I said that, well, it is not mandatory,